Okay, so yesterday I made a short video going over what I did to get some pin backs on a microcontroller when using the TFTLCD screen. I did add in the touchscreen that wasn't in yesterday's demo, so you can see the light comes on and off from the touchscreen. It's not showing up very well there, but I guess it's kind of, maybe I do that. Yeah, there. See it a little bit better. I left the touchscreen part off yesterday. I was more worried about output myself. But there's still 4 digital pins and 1 analog pin left. But that might not be enough. So I kind of hinted at other solutions. It was in my gym where the chalkboard is and wrote out a solution. So I thought I'd share this before I erase it from the board now that I've got it figured out. And obviously a picture of this is just going to look like a bunch of wires. Won't be able to tell much from the picture. But the idea here, I've got the 4 digital pins still available and 1 analog pin. And well, obviously to get some digital in and out, use some, I'll start over here with the shift registers. So 74HC595 going out, 74HC165 coming in. So that gets 8 digital out, 8 digital in. And well, obviously the serial line going out and the QH coming in, those need to go directly to the microcontroller. So that's going to take up 2 of our pins. Coming through, pulls up 2 of the pins, so now down to just 3 pins. The clock signal on both of those really needs to be controlled from the software as well. That way, just to make sure everything lines up. I guess it could be done otherwise, but it seems a whole lot easier if that clock signal's there too. So that takes up the 3rd pin. Since they would never be used together, it only seems like computers do more than one thing at once because of how quick it is compared to human timescales. But there's no way they'll be used together, and there's even a check that we'll get to here in a second. So that takes up 3 pins, just getting those 8 in and 8 out. And there's still 1 more pin needed on those, on each one, which means something else is necessary. So what I did is took the other digital pin, ran it through a 74LS90, which is a decade counter. It counts to 10 in binary. So we have 4 outputs that just go from 0 to 9 and then reset. I back that off. I only need to go to 8, so it goes from 0 to 7, and then the 8th place, which is pin D, comes around and resets it back to 0. So it goes from 0 to 7 in binary, if you're not familiar with the decade counter. Then run that into a demultiplexer to turn that 3-bit number into a control signal. So turn a 3-bit number, get 8 control signals coming out. So 2 of those are going to be used to latch and enable the shift register out, or turn off the inhibit and load the shift register in. Just essentially the same thing, but they're labeled different for a reason. There's reasons why they're labeled different, but that gives two control signals to finish out the 8 pin digital out pins and 8 digital in pins. And I wanted more than 1 analog, might want more than 1 analog input with it. So to expand that, I use the 74HC4051, which is it's a multiplexer, demultiplexer in 1. I'm only using it as a multiplexer here for input. I guess it could be turned around and used as an output with no trouble. But the first 4 control lines from the 74HC138 will be used to connect power to other devices. Which is another thing here, these will probably tie in power as well, just with all of this going on, current, depending on the situation, current might start to become an issue, so turning devices on and off might be useful. But a bunch of control signals, and simultaneously the address feeds into the multiplexer so that it'll read from up to 8 channels out. I only use 4 of them, but basically 4 analog channels in and feeding out 1 at a time based on the address here to spot in the counter. So 0, 1, 2, 3 are here, which those control lines can be used to power whatever devices are hooked to those lines. And then there's still 2 more control lines that can be used to power other devices or add in delays or something. But that was my basic idea, to add more pins to that. Before I erase it from the board, I thought I'd make a video just in case I want to. It follows up what I did yesterday. So that's the previous video will show how to get some 5 pins back while using the TFTLCD touchscreens. I'm mostly concerned with output, so that's full color display for microcontroller projects. But it restricts our pins. We might need more for the microcontroller project, so that's my plan for getting it back. Obviously not the only option, but maybe that'll inspire some ideas and ways you can get more pins back if needed.